Okay, so the last part's going to be a couple application problems. So right here, if you were, if you deposit $4,000 in the account earning 5.5% interest compounded continuously. So the good thing is we're going to be working with that PERT formula. The amount of money in the account after T years is going to be given by this equation right here. So they actually already give it to us. So the account balance after a certain amount of time, so A of T is equal to 4,000 times E raised to your rate times time. And so you'll notice they did move that two decimal places to the left to put that into decimal format. So using that equation, we're asked how much money will you have in your account in 7 years, round two decimal places. So this, we've already done problems like this actually back in 4.1. What will be new is when we get to part B. So this shouldn't be too bad. So 7 years, we're going to plug in 7 for time. So A of 7 equals 4,000 times E raised to that 0.055 times 7. Now I'm going to put this in parentheses, and we talked about this in 4.1. It's very important that I do that, especially with the calculator I'm going to be using. So depending on the calculator you're going to be using, you may have to figure that out first and then plug that in afterwards. But let me grab mine. Let's see. And the scientific calculator shouldn't be too different from the one that I'm going to be using. So here we are. And so I need to plug in the 4,000. And then if I press second and this LN button next to 4, it'll give me e to the power of. And so we'll type in the 0.055 and then we'll say times 7 and then close that. And let's see, I'm thinking it'll be worth probably around 6,000 something. Let's see. Oh, I was close, but a little less than that. So $5,878, and let's see, that would round to about 46 cents. So let's see, 58, 78, and then 46 cents. And so I had to round that 5 right there up to a 6 because of the 7 right here. Now, if it would have been like a 0.452 or 3 or 4, I would not have rounded up. But since it was 5 or higher, I had to round that up right there to a 0.46. Okay, so that one should actually kind of, you've already done stuff like that from 4.1. What's going to be different now is we're going to be asked to solve for time. And so then we have to use the skills we learned in 4.4 to help us there. So right here it says, how long will it be until you have 15,600 in the account? Round your answer to two decimal places. So what's different here is they're actually telling me what A of T is. They're telling me what the account balance will be after a certain amount of time. We just don't know the time, right? So that's what I'm going to plug in there. So I'm going to have this, I have the left side already. I know what I have here. And then 4,000 times E raised to the power of, and then I have my rate, which is going to be 0.055. And then this time I don't know what T is, so I have to just put T. And so now I'm asked to solve for this. So you actually just got done doing some problems like this in the previous parts of 4.4. And so what you have to do first is isolate the base. And so that 4,000 right there is not part of my base. So what I'm going to do is I'm going to divide both sides by 4,000. And so that'll cancel out. Now this right here, you can simplify it or not because the calculator is going to be helping us in a moment. But I might as well, you can cut off any of these extra zeros you have right here. So I'm going to cut those off. And this does reduce more. If you want to reduce it, that's fine. I'm just going to put it as 156 over 40 in case I make an error in reducing that. So I'm just, you can reduce it if you want. I'm just going to leave it like that for now. And then I'm going to leave a little space here, and you'll see why. And then I'm going to have e to the power of 0.055 times t. And then what we're going to do here is to eliminate the base e, what I have to do is take the natural log of both sides. And so that's why I left that little space right here so that I could take the natural log. Let's see. And I need to take the natural log here. Oops, there we go. All right, so what's going to happen there is when you take the natural log base e, that's going to cancel that out, and it's going to reduce it to what the exponent is. So now, let's see, I'm going to come over here where I have a little bit more room. So I'm going to have the natural log of 156 divided by 40 is equal to 0.055 times t right there. And then now we'll go ahead and divide by 0.055. 0.055. And so that's going to be my exact answer right there. T is equal to the natural log of 156 over 40 divided by 0.055. And then to get my exact answer, we're going to take this and stick this in the calculator and round 2 decimal places. And so this shouldn't be too bad putting it in the calculator. Let's see. So I have to start with the natural log of 156 divided by 40, and then close that parentheses right there, and then divided by 0.055. And so let's see, I'm going to throw out a guess here. It's probably going to be around 20 years, I think, maybe give or take. Let's see. Okay, 24.7, we're going to have to round that to 7.5. So 24.75 years. So 24.75, 24. So anyways, I'm kind of throwing out these guesses because I want you to kind of think about reasonableness. Because if your answer came back as being negative or as being, 1,000 years or something like that, you would know that something might have got typed in wrong or something went wrong along the way. So kind of try to keep that in mind as far as reasonableness. I've kind of said this before, a good rule of thumb is the money, typically, it kind of depends on the rate, but should double about every 10 years or so, give or take. And so we were at 4,000. So after 10 years, it would be, 8. And then after another 10 years, it would be 16,000. So that was why my guess was about 20 years. Now, our rate was it's 5.5%. The typical rate of the stock market is about 7%. And that's where that doubling about every 10 years comes in. So that's why it was a little bit more than every 10 years in this example. Okay, let's see. Part C, and I think this is the last part. It's about how long will it take for the money in the account to double? Round your answer to decimal places. Okay, well, let me grab a snippet of the equation and let's look at that. Okay, so if it's going to double, my initial amount, remember, was 4,000. So then this would be 8,000 right here if it were going to double. And then e to the power of 0.055t. And this is going to be very similar to the one we just did. It'll actually probably be a little bit nicer, actually, because I'm going to divide by 4,000 to get started. And so once again, I can knock off those zeros. And then 8 divided by 4 is a 2. So that's going to make just, the numbers a little bit nicer as far as plugging it in and stuff. And then once again, I got to kind of sneak in here, and I'm going to take the natural log of both sides. And what that will do for me on the right side is it'll cancel that out and reduce down to my exponent right here. And so we're going to be left with natural log of 2 is equal to 0.055t. And then the last thing I need to do is divide by 0.055. And so then that's going to cancel out here. And that will give me my answer. So let's go ahead and look at that. And it's probably going to be, like I said earlier, it was close to doubling every 10 years, but it was a little bit more than that. So I'm thinking it'll be around 11 or 12, something like that. So let's see, natural log of 2, and then divided by 0.055. We'll press enter. So 12.60. So 12.60. So a little bit over 12 and a half years, which isn't great, but it's not bad if the money's, if you're working towards retirement and you have extra money to set aside. It's not great, but it's better than it staying the exact same for 12 years, right? So if you had an extra $4,000 laying around in 12 years, 12 and a half years, it's not going to be quite worth as much as it was. Like it's not going to buy you as much, right? But if you were able to double it and have 8,000, well, then it would probably be worth about what has occurred over the 12 years of inflation or so. Hopefully you're a little bit beating inflation. But anyways, that's kind of the idea of investing towards retirement is get that money in early so that when it's time to retire, it's going to be worth the value you need it to be able to afford things at that point with the inflation. If you don't invest it, then you're really just kind of throwing away that money if you're able to set aside a little bit each month for retirement. Okay, enough of that. I'll get off my soapbox, but that is going to conclude Unit 4. And so we have one last little thing we have to look at, and it actually comes from a different chapter. And so if you have any questions or concerns about this, just let me know, and let's move on.